solving simple problems involving subtraction of common fractions. Now let's look at task 1.
Peter John bought an 8-slice circular pizza. He decided to give his little sister, Alexia, 2 slices. How much of the pizza does he have left for himself?
Okay, so Peter John had an 8-slice pizza and he gave his sister 2 slices. So that's 8 subtract 2. Peter John has 6 slices remaining.
That sounds about right. Did you say 6 slices? Excellent job. Now, what if we wanted to represent this same scenario using fractions? What would it look like? So we have a whole pizza. How much slices did a whole pizza have?
8 slices.
What was Alexia's share?
Alexia got 2 slices.
What about Peter John? What did he have?
And Peter John had 6 slices remaining.
Let's pay a little more attention to the fractions. So the whole pizza was divided into how many slices again?
8 slices.
Which is denoted by the denominator of the first fractional representation. How many out of those 8 slices do we still have in the whole?
So we still have 8 slices.
Excellent. So 8 also denotes the denominator. So the fractional representation for the whole pizza is
8 eighths.
excellent. Alexia received 2 slices out of the 8 slices that were there. So Alexia's fractional representation or fraction that she received was 2 eighths. How much did Peter John get again?
And Peter John now has 6 eighths remaining.
So if we start out with a whole pizza, we subtracted 2 eighths of that whole pizza, the remaining portion would be 6 eighths.
Now, let us look at some points to note. What is a fraction?
A fraction is an equal part of a whole. Now that whole may be one thing, as you can see in this diagram, or it may be a set of things. So a group of people can be considered as a set, or a group of things can also be considered as a set.
What does the numerator and the denominator of the fractional representation represent?
The numerator represents the number of parts being considered out of the whole, while the denominator represents the number of parts the whole is divided into. Try to remember these points.
Now let's explore.
So task 2. There is a meeting of all grade 11 boys today in the main hall. There are 10 students in your class. Half of them are boys. When the boys leave, what fraction of the class is left behind?
So let's look at that.
So let's before we even do that, let us put the class on the board for everyone to see. How many students are in the class again, Brittany?
There are 10 students in the class at present.
So that whole class
Is divided into 10 students.
Okay, so each student in that class is a part.
Yes.
Good. So how many students are present in the class before
10
the boys?
students.
So we have 10 students in the class. So the whole class can be represented fractionally by
10
tenths.
tenths.
How many students are leaving?
Half of the class is leaving.
All right, so I'm just going to put half. Now, can I subtract this half as is?
No.
All right, let's look at what we need to do. So when we have a whole, remember what we said, a fraction can be, it is an equal part of a whole. That whole can be one thing or it can be a group of things. All right, so we have our whole and we've divided the whole into 10 equal parts. Each part is a student. Now half, what if we were to divide that same class into 2 equal parts, which would now make it half. So let's look at that half. Let's look at how many tenths we would need to make that half. 1, 2, 3, 4, 5. So the whole can be divided into 10 parts. Half of that whole is always going to be half. But in this instance, half of the 10 parts is 5 out of the 10, or 5/10.
That would be correct.
Now let's do the algorithm for that. So we have 10 as our whole.
Yes.
The parts our whole is divided into. In the class, we still have our 10 students, which still is 10 tenths, our whole. Now, how many tenths will make our half? 2 divided into 10 gives us 5. So what we're saying, 5/10 make the half. How many halves do I have, Brittany?
You only have 1 half.
So 5 multiplied by 1 gives me 5. So 5/10 represents my half. What I've done is I have represented both fractions with the same
Denominator.
which means I have pretty much, what does it?
So we've just found some equivalent. We've just found an equivalent fraction.
So a half is equivalent to 5/10. So 10 subtract 5 gives us 5, and our whole is still 10 persons. So 5/10 represents what is left, and in this instance, the persons who also left. So 5/10 of the class went to have the meeting, and 5/10
Are remaining.
excellent.
So let's check our solution. So that's correct. Now, what are the main points to note?
Let's go. Why is it important to create equivalent fractions when subtracting fractions with unlike denominators?
Well, equivalent fractions allow us to see each part of the same whole.
So our first question,
Which of these fractions has the same value? So here we're looking at what again?
1/3, 3/6, oops, and what is that? 4/8, and
4/6.
I hope you can see that last one. All right. So we're asking which of these are the same. When you look at a third, you need to understand what a third is. What does the denominator tell you again?
How many parts my whole is divided into?
Okay. So for this fraction, the whole was divided into 3 parts, and I have 1 out of the 3 parts. All right. For this fraction, my whole is divided into
6 parts.
and I have 3 out of the 6 parts. For this one, 8 parts, and I have
4.
6, 4. Which, in your mind, is the largest fraction?
The one with the biggest denominator?
Ah, look at that. It's not a misconception.
It is.
So, a third. So, if you think about it, if you had a pizza and you were sharing up with 3 friends, wouldn't you get more than if you were sharing up with 8 friends?
You know, I think you may be right, because my slices may be a little bit bigger if it's 3 of us rather than 6 of us.
So, we must remember that the smaller denominator tells us that that one unit, that one, what should I say? The 1/3 is always larger than the 1/6 or the 1/8, because this fraction represents a larger part of a whole. Now, let's look at what this represents. So we pretty much want to benchmark these fractions and see where we're going with it. So, is there anything here that represents, that may look like a third?
We may have to simplify our fractions.
Let's do that.
Okay.
Or we can even look at, all right, so let's see. Is there a multiple that all these denominators can be referred to?
Let's see.
18?
Yes, I think you're right. No.
3? No? 8. 8 can't go into 18. What if we did another
24,
thing?
24.
Okay, let's see. 24. All right, excellent. So 3 divided into 24 goes 8 times.
Yes, that's correct.
and we have only 1/3. So it's 8 times 1, 8. 6 into 24.
4 times
4 times 3.
12.
Plus
Come on.
8.
8 into 24.
3. 3 times 4.
12.
6 into 24.
4 times
4 fours.
16. Oh, I think you mean comma.
Oh, I'm so sorry.
Yes.
We're not adding, are we?
No.
We're looking at the fractions separately.
We are.
I do apologize. So we have the 1/3 can be rewritten with 24 if we were to divide all these wholes into 24 parts. The 1/3 will be represented by 8 24ths.
Yes, that's correct.
The 3 6 12 24th, 4 8s 12 24ths, and the 4 6 as 16 24th. Which two are?
The same. So it looks like 3/6 and 4/8 are the same fractions. Are equivalent fractions. They both represent a half.
Yes. And you could have examined it as well and see that 3 out of 6 is half of the total, and 4 out of 8 is also half of the total. So you could have examined the fractions without even doing this and realizing that this 3/6 is equivalent to 4/8 because it represents half.
So the value is the same. So let's look at this question. A carpenter has a length of wood measuring 5/8 meters. He cuts a 1/4 meter length from it. How much wood is left?
Okay. So what do we know again?
We know that the carpenter has 5/8 meters of wood.
Okay, so he started out with 5/8 meter.
He cuts off a 1/4 meter.
So he would be taking away a 1/4 meter.
That's correct. And we are now trying to find out how much wood this carpenter has left.
All right. Now, in this particular problem, you're referring to the hole that he has as cut up into 8s.
Yes.
And they're also referring to it cut up into 4s. Right.
Yes, and he's taking out a 1/4.
So let's see if we can bring all of them to both quantities, I should say. So a 1/4 meter versus a 5/8 meter. Still 1 meter that we're looking at. Want to take this one?
Okay, so our hole in this case is divided into 8s. So we want to create an equivalent fraction of a 1/4. We want to rewrite it as 8s. So our denominator, or in this case, is going to be 8. Okay, so we have 5/8 to start off with. And we're now going to be subtracting a 1/4 meter from my 8s. Now, how can I rewrite my 1/4 as 8s? Looking at the algorithm, we could just simply go, how many times can I get 4 out of 8?
Or we can ask a question, how many 8s is required to make a 1/4?
That's true.
So 4 divided into 8 gives us 2. So what that is telling us that 2 8s will be equivalent to
a 1/4.
A 1/4. So 4 divided into 8, 2. We only have 1/4, so it's 2 times 2, which is 2. So 5/8 subtract 2 8s gives us
3/8.
3/8.
So we would have 3/8 of the wood left. So it's 3/8 meters that would be remaining.
There you go.
Now let's look at another question. A bag of tomatoes weighs 3/4 kilograms. What weight is left after using 1/2 kilogram of tomatoes?
So let's talk about this a little.
Okay.
We have 3/4 of a kilogram. How many quarters is in 1 kilogram? How many quarters make up a kilogram? So we'd say 4. 4 quarters would be the whole. Now, what weight is left after using a 1/2 kilogram of the tomatoes? Is there a relationship with quarters and halves?
I think there is.
So how many quarters make a half?
2 quarters?
So 2 quarters. So I can just really look at this and tell that a half it can be
Equivalent to 2 quarters.
So if I were to have 3/4 of a kilogram,
And I took out 2 quarters,
I would have
1 quarter remaining.
good. So I've pretty much reasoned that one out.
So there we go. We have a 1/4 kilogram of tomatoes remaining.
And as you can see, we would have found an equivalent fraction in terms of quarters to represent our half.
That is right. Now let's look at this question. We are going to find out 9/10 subtract 2/5. So we have 9/10 subtract 2/5. Now, we've been doing this for a little bit.
I was just thinking the same thing, that you should realize by now that when we have fractions with different denominators, we don't just go straight ahead and subtract. We have been finding equivalent fractions in terms of one of
The wholes that we're considering.
Good.
So in this case, our whole is divided into how many parts?
This was the first fraction, this whole is divided into 10 parts.
Okay.
And this one, we can see that the fraction, or the whole I should say, is divided into 5 parts. Now think about it, just before we go into the actual working of this problem. If, and I said it before, if I had something divided into 10 parts, and so I had a pie, and I divided one of my pie into 10 parts, I divided another pie into 5 parts, and I told you that you could take 2 slices, right? Mm-hmm. Now, I don't think you're going to take from the one that I divided into 10 parts.
No, sir.
You're going to take the one that I divided into 5 parts.
Yes.
That means the parts are different. The parts that comes from the pie that was divided into 5 parts are larger. And the one that came from the pie that divided into 10 parts are smaller. The parts make a difference. When you look at the denominator, it tells you how many parts the whole has been divided into.
That's
So
true.
now, let's go back to this. So we can't just operate when the denominators are different, because it tells us much more than just the value that we're seeing here. So we have to represent both fractions with the same
Denominator.
Okay.
So we need to find equivalent fractions, or a fraction that's equivalent to.
the 2/5. So we know that we have, so we look for a common multiple. In this case, 10 and 5, the lowest common multiple is 10.
Yes.
So we know that since this is already in terms of tenths, we have 9/10 working with, correct?
That is true.
And now 5, how many tenths will make a fifth? 5 into 10,
I
5
believe-
divided into 10 goes.
2 times. So that's 2/10 make 1/5.
And how many fifths do we have?
And here we have 2/5.
Therefore, 2 times 5 gives us
4/10.
2 times 5?
2 times 5 gives us 4.
No, 2 times 5 gives us 10, but 2 times 2
Gives us 4.
All right, so 9 subtract 4/10, 9/10 subtract 4/10 will give us?
5/10.
All right, I put it here because I don't want you to miss it. So we have 5/10. So if you were to subtract 2/5 from 9/10, you would make them equivalent fraction. You would find an equivalent fraction for 2/5, which is 4/10. So 9/10 subtract 4/10 will give us
5/10.
5/10. I know you got this, I know you did well on that one.
And that is correct.
Try this one. We're giving you a second to try this one on the screen.
So what is 3/5 subtract 2/10?
A few seconds. A second is a bit sudden upon you. Hope you're ready. So 3/5 subtract
2/10.
2/10. You know this already. We're going to make these fractions. We're going to make sure we're working
with the same denominator.
So you have been here before, 5 and 10, lowest common multiple, 10. How many tenths make a fifth? We said 2.
Yes.
How many fifths do we have?
3,
So 3 times 2.
6.
I'm going to put it here for those who need to see it. 6. And this is already in tenths, so it's 2 tenths that we are subtracting. 6 tenths subtract 2 tenths gives us
4
2
tenths. So in this case, we would have 4 tenths remaining. Let's check the screen. Oh,
There
we're
you go.
correct. So let's look at a summary of what we've done today. There are 3 simple steps to subtraction. 1, make sure that the denominators are the same. Now, when we refer to the denominators, we're referring to our bottom numbers.
Okay, so remember, if they are not, now what if, I'm not sure if we did. Yes, we did. The first example we had 8 eighths subtract 2 eighths. So the denominators were already the same. So when they are the same, you just operate. So it's 8, so you just subtract the numerators. So 8 subtract 2 gave us
6.
6, and we kept the 8 because we're working with that one whole that we're subtracting from, which was divided into 8 parts. However, if we are working with the same whole, but we're referring to that whole in terms of fifths, and we're also referring to that whole in terms of tenths, we must refer to them in only one partition.
Yes. So in this case, we need to form equivalent fractions.
So we found an equivalent fraction in terms of tenths for 3 fifths, which was 6 tenths. And we remained with the 2 tenths, and we got 4 tenths. So the next one, so make sure your denominators are the same. Step 2.
And final step would just be to simplify if it is needed. In this case, could we have simplified our fraction any further?
Most definitely.
So we have 4 tenths, and if we were supposed to simplify further, what would we have?
How do we know if it can simplify, though?
They should have
Common factors.
Yes.
So it's 4 and 10. Do they have any common factors?
I think 2.
2. So we can divide 4 by 2. So I'm just going to write it out here. Divide each value by the same number. So 4 divided by 2 gives me
2.
2. And 10 divided by 2 gives me
5.
5. So
So the simplified fraction would be 2 fifths. That's all the
seems
time we have for today's
that's right.
lesson.